Hi, how you doing? It's Bob Sorensen. I'm putting on my SVP for research hat to give you a quick overview about some of the challenges and opportunities about navigating the new world of HPC and AI and quantum and clouds and whatever else is out there today that we're going to find out about at ISC and going forward. Let's just talk about how the HPC landscape is undergoing significant changes again. One thing that's constant in HPC is that nothing is constant. And what we're seeing now are multiple developments significantly altering the overall HPC landscape. We're seeing applications in machine learning and deep learning, and certainly generative AI is a near term game changer. Lots of interest, lots of potential, lots of uncertainty of its ultimate value added within the science and engineering community, which is really the foundation of HPC going forward. We see opportunities computing at the edge, specifically to support real-time decision making. The idea that data and analysis needs to be done in the short term in order to make quick analytical decisions for a wide range of applications. We're seeing CSPs and their HPC related impact as they move to address not only the wide range of users who are interested in accessing images or instances of HPC specific virtual machines, but also in looking in terms of bare metal offerings and other ways that CSPs can weigh into the overall HPC environment. We see end users' decisions scratching their heads about balancing on-prem and cloud and private and hybrid. Where do they go? What's the most economical performance solution for their particular workloads? We see dark HPCs on the horizon, organizations that are assembling their own PCs that won't ultimately appear in the traditional HPC revenue stream. Organizations like Facebook and Tesla and OpenAI slash Microsoft who are looking at building HPCs for their own internal purposes that don't really require a traditional HPC systems vendor that we're used to for the last 40 years or so. We certainly see quantum computing making strides going forward. Again, another point to be considered in the calculations about how you equip a modern HPC center going forward. But we cannot deny the fact that traditional mod sim will remain a critical element in all this. So, as we said, no one size fits all. HPC systems, in reflecting this varied decision making process, are becoming more complex due to the diverse workloads they have to address, and that variety in workloads demand variety in architecture. And basically, what that means is accurately characterizing workloads is imperative, and simple benchmarking is no longer enough. In fact, you could argue that the top 500 list, because it is so pervasive and yet so limited in what it measures, can actually be harmful to the sector. Because if you optimize for top 500, there's a very good chance you end up with a system that is not well suited to basically deal with some of your most important applications. Well, happily, there are technical options available to address this evolving option environment. Excuse me. There's some on-prem trends that are moving away from monolithic architectures towards more flexible, heterogeneous designs, multiple hardware partitions, such as the Jupyter system, due out in the Euro HPC JU site in Germany next year. We're seeing much more cloud-based options, as I mentioned earlier, more image types, bare metal options, CSP, HPC as a service is what we see with Microsoft and UK Met in terms of supporting an on-prem replacement for UK Met with a Microsoft monitored system. We're seeing experimental novel hardware access, the use of containers. All these things really allow end users to adapt the most optimal hardware and software solution to meet their most compelling workloads. We're seeing a sampling of options for underlying computational engines like explosion processors, x86, ARM, RISC-V, different kinds of super chips, NVIDIA Grace Hopper, the AMD MI300, and all a host of accelerators out there, both from major players like NVIDIA and AMD, but also and Gaudi from Intel, but also a lot of AI specific startups looking to really adjust and perfect and customize AI chips to meet contending workloads. This chart is just a simple overview of really what's going on in terms of different workloads requiring different solutions. You can perhaps explore this at your leisure if you're interested. But to me, some of the interesting things, if you look at the row about data formats, in ModSim, it's all about 64-bit floating point, big data, 64-bit floating point, or integer. Large language models, low, mixed, or AI specific precision formats. And here we're talking about some cases, maybe 2-bit precision, 4-bit precision. Cloud based HPC, anything goes in a virtual environment. So you can see that the kinds of workloads you have really can impact something as fundamental as the data format you're looking at. If we look at moving away from kind of the classical world, we look at what's going on in the quantum computing space, another decision point for a lot of HPC end users going forward. who are specifically speaking, the major concern about quantum computing end users right now is that they want to accelerate their existing performance capabilities in a way that is not trivial using classical hardware because of complexity, trailing off of performance gains due to physical limits such as Moore's law, as well as power consumption and general difficulties in obtaining the classical system that meets your workload requirements. So quantum is something that people are looking at, and they're eager to explore the new algorithms and the new performance advantages that quantum can bring to the table. Likewise, we're seeing lots of interest in HPC related large language model activities. And this is a list of activities that we polled a number of HPC centers that are looking at large language models today for science and engineering applications. And we asked them, what particular activities are you are undergoing right now within your organization? As you can see, the most popular was it is exploring the range of potential performance enhancements using integrated LLMs. And what's interesting is if you look at almost 60% of the organizations we polled said they're conducting those activities, but within the 12 months hence, only 48% will be doing that. In other words, there'll be a drop in the exploration. But where we see some significant increases instead is testing and assessing large language models integrated into workloads. We're seeing an increase in things like standing up limited LLM pilot programs or even running production level LLM enabled workloads. So organizations are already starting to explore some of the advantages, some of the performance potential of large language models going forward. What this really just shows you is that there is such a mix of opportunities out there for the end user that navigating this mixture of opportunities means that you could get some very performant systems at a very good price point. But if you make the mistake and you don't accurately characterize your workload and implement a hardware complement, a software complement that meets the requirements of those workloads, you could spend a lot of money and get some rather disappointing performance well below what you could achieve with a much more optimized and performant efficient solution. So that's really something to think about. We can talk about this more at leisure if you want. Here's my email address. Drop me a note. Otherwise, I hope you found a little bit of this useful, and I hope you enjoy the rest of ISC and have a good week going forward. We'll talk to you later now.